We are live. We are live. Yeah, we're live. Okay, good. So let's see. It is 8:30 August. I can't believe we actually go to school in August. It just seems wrong. Okay, our objective today is we're talking about linear graphs. Okay, so the word linear. When we talk about linear, we are talking about straight lines. Okay. Linear graphs are straight lines. And they're also of degree 1. Because that's that invisible 1, right? X to the 1 power. Okay, so when you see anything that has x to the 1 power, well, at least for a while, then you know it's got to be a straight line, okay? Now the quadrants, it always amazes me that a lot of kids don't know about the quadrants, but that's okay. They're pretty easy. If you've seen the quadrants before, awesome. If you've never seen the quadrants before, let's check it out, okay? Because someday in college, they're going to talk about the quadrants. So x-axis, y-axis, right? In the very middle is called the origin. The origin is the middle point, which is the coordinate 0, 0, right? Quadrants, well, the word quad means 4, right? Doesn't the word quad mean 4? And it is broken up into 4 parts. So we label our quadrants using Roman numerals. Quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Someday in here, it's going to be important to know the signs of the quadrants. Right, Brittany? Mm-hmm. So we know that if you have any point in quadrant 1, the x value is positive, and so is the y value, right? You know that, but someday that's going to be really an important thing. If you're in quadrant 2, any point in quadrant 3, you have to go back and then up. So any point in quadrant 2 is a negative x and a positive y, right? Any point found in quadrant 3, you have to go back and then down. So it has a negative x and a negative y. And any point found in quadrant 4 is over, then down. So it's going to be a positive x and a negative y value. Okay? And you probably know that, but it's good to look at this because this is going to be important later. Okay? Now, midpoint formula. Well, here it is. Let me give it to you, and then we're going to talk about it. Midpoint formula. So it's a point. Okay, it's a point, midpoint. It's a point. So if it's a point, it's going to have an x and a y value. It's a point, right? And if it's a midpoint, it's just the average. Just the average. So it's your x1 plus your x2 divided by 2, comma, because it's a point. And then it's going to be a y2 plus a y1 divided by 2, okay?
Wait, so you don't do y1 and y2 like you do it in the opposite order?
Oh, I did do it in the opposite order.
It doesn't matter for the opposite order.
And I did it that way on purpose because it doesn't matter, does it? Good observation. Or y1, y2, or x2. It doesn't matter. You add the x's. Thanks, Lauren. Divide by 2, add the y's, divide by 2. So let's look at an example, okay? Real quick, we'll do an example. And my example, let's say I have point A, which is at, let's say, 3, 7, and point B, which is, say, at negative 5, negative 3, okay? Every point has an x and y value. Since this is my first point, I'll call this my x1 and my y1. This is my second point. I'll go and call this x2, y2. So every point has an x and y value. I chose this to be my first point, so x1, y1. I chose this to be my second point, so x2, y2. And again, Lauren brought up a really good point. It wouldn't really matter if this is x2, y2, and x1, y1. The idea is we're just going to average them. So the midpoint would be, on this example, would be a 3 plus a negative 5 over 2. I'm adding the x's. Comma, 7 plus a negative 3 over 2. I'd have a negative 2 over 2, which is a negative 1. I'd have a 4 over 2, which is a 2. Okay, you guys see the negative 2 over 2? Give me a second to see it. Negative 2 over 2. I just skipped a step. I'll put it in there, negative 2 over 2. And a 4 over 2. Okay. Now graphically it does look like this. Okay, it's worth looking at the graph because it should make sense. I mean, it really should. I mean, we just did some numbers. What does it really mean? You don't have to necessarily do it graphically, but I'm going to show it anyway, okay? 3, 7, 1, 2, 3, 1, 2, 3, 4, 5. So, okay, I want to do that one more time. One more time. Taller graph. Okay, 3, 1, 2, 3, 4, 5, 6, 7. There's A. Negative 5, 1, 2, 3, 4, 5. Negative 3. There's B. So AB has to be a line segment because you can't have a midpoint of a line. I'll say it again. You cannot have the midpoint of a line. I'll say it again. You can't have the midpoint of a line. How come? Why can't you find the middle of a line? Ellie. It goes on forever, right? You guys agree? So it has to be a line segment. Okay, so where's the midpoint? Well, according to this, it's at negative 1, 2. Sure looks like that's the middle, doesn't it? Okay. And sometimes you guys can do this graphically, but sometimes the numbers are so ugly that you need to really just do the math, okay? Now the distance formula, and I also want you to make sure when we give the distance formula, okay, make a star, length. Oh my goodness. I know, I've been teaching forever. You guys know that, right? Teach forever. Oh, the worst thing that happens in almost every book is they talk about the distance formula. And the question in the homework says find the length. Half the kids are like, Mr. Davies, I don't know how to do this. Well, length and the distance are the same thing, aren't they? So if it says, okay, find the length of AB, you're going to really find the distance. Same thing, right? Okay, good. I know somebody's going to ask me anyway. It's going to happen. I'll say go see Brittany. Okay. Okay, so then the distance formula. Well, if we took a look at AB, okay, and we go back to Pythagoras' theorem, I'm just going to show you. You don't have to write this down. If I go back to Pythagoras' theorem, I can create a right triangle, right? We know a squared plus b squared equals c squared. So when you look at the distance formula, which I'm going to give you in a second, it is Pythagoras' theorem. You'll notice it is going to be a squared plus b squared equals c squared. Now, how long is this? It's the difference between these two x values. How long is this? The difference between these two y values. Okay, so here it is. The distance formula looks like this. D for distance or length is the big square root of parentheses x2 minus x1 quantity squared plus y2 minus y1 quantity squared. That's the distance formula. Basically, that is Pythagoras' theorem because it is a squared plus b squared equals c squared.
Something I want to point out, since it was brought up with the midpoint formula, is that you cannot switch these around.
No, you can't. You
because they
can't.
have to match each other.
Yeah. Thanks, Brittany. Yeah, it has to be in the right order, okay? So then, if I want to find the length or distance of AB, then I've got my points, which happen to be my 3, 7, and my negative 5, negative 3. I would go D equals the big square root of, okay? Here's my formula. We called this one x1, y1, right? We called this one x2, y2, right? And so I'm just going to put the numbers into the formula, okay? I'm just going to put the numbers into the formula. So I'm going to go x2, so I'll go negative 5, subtract x1, which is 3 squared, plus y2, which is negative 3, minus y1, which is 7 quantity squared, okay? So I'm just plugging them into my formula, into this one, x2, x1, y2, y1, okay? So then, if I simplify this, I'd get negative 8 squared plus negative 10 squared. Negative times a negative is a? Negative times a negative is a? Everybody, negative times a negative is a? All right, so 64 plus 100, right? Everybody agree with that? Square root of 164. That probably reduces 41, I don't know, anyway. Or if it reduces, I don't know what it is, or you can use your calculator approximately. I don't know what the square root of 164 is. Sometimes I want square root answers, sometimes I want decimals. Let's see what square root of 164 is. Square root of 164. Clear, 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 square root. Oh, clear, come on. Square root 164, about 12.8. Okay, how's that? Thumbs up? Okay, not too bad. Okay, now, x and y in intercepts, okay? So here's what we know. I know that, and I'll go back to my graph, this is a x-intercept right here. This is an x-intercept, okay? Does that make sense? What is the y value right here? What's y value right here? Good, good, totally right. So if I want to find an x-intercept, let y equal 0. That makes sense, right? An x-intercept would have a y value of 0. Here's my x-intercept. I'm sorry, my y-intercept, I said wrong. Here's my y-intercept. What's the x value?
0.
So if I want to find the y-intercept, let x equal 0. And I'm going to just do a real quick sketch because it's worth having a sketch so we can see what I'm talking about. I'm just going to do any old sketch, but so that you can see it, right? There they are. There they are, okay. X-intercept, y is 0. Okay, so now, how does that help? Well, in example 1, what we've learned in the past is we could solve for y, correct? Solve for y, graph it. You guys have done that, right? There's an easier way. We're going to graph this by, we're going to sketch this graph by intercepts. So I'm going to show it, and then I'm going to do it mathematically, okay? So I'm going to do it these way, because we're smart, okay? This is not pre-calc for dummies. No, okay? Check it out. Okay, if x is 0, x is 0, x is 0, boom, what's y? 9. We could graph that, couldn't we? If y is 0, y is 0, what's x? We could graph that. Boom, boom, line's done. Let me show you. Did you follow that though? Let me show you. Let's do it, okay? Isn't that easy? I said, come on, let's make math easy, right? So, what I just showed you, you can do in your head, but I will show it on paper. But let x equals 0. I'd have a 3 times 0 plus 2y equals 18. 2y equals 18. Y equals 9, right? So, 1, 2, 3, 4, 5, 6, 7, 8, 9 is the point 0, right? 0, 9. I know that we probably already have the graph, but I'm going to show the work anyway, okay? Because if you do it, they call the cover up, you have it done, okay? And if I want to do the other intercept, I'll let y equals 0. Well, I'd go 3x plus 2 times 0 equals 18. 3x equals 18, x equals 6, right? 1, 2, 3, 4, 5, 6. That's the point 6, 0. Connect the dots. I got it, okay? How's that? Isn't that easy? Now, I made it hard because I showed all the work. It's just going to be this. So from here on out, if it's in standard form, you just know that, boom, y is 9. You see it? Boom. X is 6. Isn't that easy? Here's your line. But I just showed you why. Because I want you to know why. It's important you know why. Okay, that's called the cover-up method. I hate using that word because it doesn't mean anything, right? Okay, on the back. Example 2. Given A and B, find the midpoint, mind point, find the mind point. Find the mind point. Oh, man. Okay, and the length. Okay, so let's do that. Okay, you guys find, go ahead and try it. Find the midpoint and the length of AB. See if you can do that. Okay, you've got your formulas on the front. Okay, see if you can do it. There's your formulas. I'll highlight them. See if you guys can get these, okay? Here's your midpoint formula. And there's my distance, okay? See if you can do that. And if you get stuck, I'm going to do it with you, okay? So you can see it. Oh, come on, Bill. First day back. There's my midpoint, but I'll let you guys get it. And distance. Okay, there's my answers. See if that makes sense. Thumbs up on midpoint, everybody? Everybody get it? How about length? So show me thumbs up if you got both, okay? Okay. Everybody got it? Okay, I'm going to move on. Okay, number 3, graph the system. So first of all, what's the easy way to graph? So I've got 2x plus 5y equals 10. Tell me, what's the easy way to graph that? Yeah. Yeah, so if I cover up the x, what's the y? 2. So 2. If I cover up the y, what's the x? 5. Okay, everybody agree with that? Bam. Piece of cake, right? I know you guys are like, Mr. Davies, how come you never showed us that, huh? I might have. Okay, so then the other one. Okay, if I cover up the x's, what's the y? If I cover up the y, what's the x? All right. So the solution is the point of intersection. So the solution is the point. But I got a question mark because I'm not really sure what the point is. Say that again. I don't know what the point is. Yeah, okay, so the coordinate of the point. So if I have to be accurate, I mean, I could guess. It looks like about 2.5, maybe 1.25. You guys with me? It's about 2.5, maybe 1.25. But if I have to be accurate and know the exact answer, we're going to do it by elimination. Let's see if you remember elimination. So, you ready? I'll go through this with you slowly. I've got a 2x plus a 5y equals 10 with a 3x plus a 4y equals 12, okay? Okay, elimination. Eliminate. Let's eliminate the x's. So let's eliminate the x's. So, if I make this 6 and this -6, if I make this 6 and this -6, what happens to the x's? Eliminate, right? How do I make this 6? Divide by 3. How do I make this -6? Multiply by -2. It's kind of like a common denominator, okay? So let's eliminate the x's, okay? So I'm going to go ahead and multiply this one by 3 and this one by -2 because I know that will make them the opposites and they'll eliminate, okay? So let me rewrite my equations. I'll have a equation 1, equation 2, okay? Equation 1 now becomes a 6x plus a 15y equals a 30. And equation 2 now becomes a -6x minus 8y equals -24, okay? So I want to eliminate, right? It says by elimination, so I want to eliminate. And I'm pretty sure now that my x's will eliminate, right? So I'm going to add the equations, and my x's are eliminated, right? So then I'm left with a 7y equals 6. Divide by 7, y is 6/7. Now that's the exact answer. I was guessing at, I think I was guessing at x. I must have graphed pretty poorly because I was guessing at 1.25. That's the exact answer. But every point has got some x value. So it's something 6/7, right? How do I get the x value? How do I get the other part? How do I get the x value? Lauren? There you go. So we're going to substitute. So we got lots of places to put it. We can put it in equation 1, equation 2. It doesn't really matter. Lauren, what do you want? Equation 1 or equation 2?
Equation 1.
Okay, we're going to put the 6/7 in for y. Equation 1. So I bring equation 1 down here. So I'm going to go 2x plus 5 times 6/7 equals 10. Okay. I'm going to have to deal with fractions, but fractions don't scare me. I can do it. I can do it. So I've got 2x plus 37 equals 10. Let's see. 7, okay. Minus 37 minus 37. Okay, so how am I going to do that? Well, one way is you can make this into 77s. Another way you can do is change this into, let's see, what is that? Is that 4 2/7? Probably make it easier to make that 4 2/7. So 10 minus 7 goes into 30. 7 goes into 30 4 times with 2 left over. Do you guys agree with that? If I subtract these, then I'm going to get 5 and 5/7. How's that? Okay, that's all I have. Oh, I got to divide by 2. Oh, shoot, I got to divide by 2. Brittany, thank you. Aren't you guys glad Brittany's here? Oh, 35. That's the same as 35. 47. Divide by 2 27ths. Oh man, I made a mistake. 27ths. Sorry about my mistake. 27ths and 6/7. Brittany, I'm glad you're here. Sorry, my bad. So I changed it into 47ths because it made it easier to divide by 2. So I went, okay, ready? 7 times 5 is 35. 35 plus 5 is 40. And I made it that way because then I could divide that by 2, okay? What's that? 2 and 6/7? Yeah. Okay. Let me get you out your homework.